Hi, this is Dr. Sebastian Rushworth. Welcome to my podcast. My guests today are Professors David Raubenheimer and Stephen Simpson, who are biologists at the University of Sydney in Australia. And David and Stephen have dedicated their careers to trying to understand how animals decide what to eat and how much to eat. And they've written a book called Eat Like the Animals that chronicles their research journey and the discoveries that they've made. And one of the central ones that we're going to be talking a lot about is this idea of protein leverage, which can really pretty much single-handedly explain why we're currently experiencing an epidemic of obesity, and which also tells us in very clear terms what we need to do to reverse the epidemic, to reverse obesity in those who are suffering from it. So please enjoy my conversation with David Raubenheimer and Stephen Simpson. Hi, David and Stephen. Welcome to my podcast.
Thank you, Sebastian.
Hi, Sebastian. Thanks.
Your book really provides a very convincing answer for why we have this current epidemic of obesity, and I want to get back to that. But I guess we should probably begin with the basics. So maybe you could just tell the audience what protein leverage is and what the protein leverage hypothesis is.
Well, protein leverage, I think we need to go back a step, and that is to the discovery that animals, including ourselves, don't have a singular appetite. We don't just feel full or hungry, satiated after eating. It transpires, and we were pioneering in this area, but other biologists before us and at the same time developed similar insights. We have specific appetites for different nutrients. And there are many, many possible nutrients that you could have a specific appetite for, but there's actually a rather small number that animals have time and again evolved in their natural environments, and they tend to include the macronutrients, protein, carbohydrate, and fat, and some of the micronutrients, salt and calcium, for example, two of the essential minerals. And those appetites, we showed very early on, have evolved to work together to help animals in natural food environments to balance their diet and solve the massively complex challenge of attaining nutrient balance in dozens of different nutrient dimensions. So then that begs the question, what happens if those appetites they're not working together, but they have to compete with one another in a nutritionally imbalanced environment? And we went on to show in a range of species, not all, but certainly a number across many different taxa of animals, including in humans, that the protein appetite tends to dominate if put into competition with the other nutrient-specific appetites. And indeed, even the control of calorie intake. And what that means is that if you take an animal that shows this dominant protein response in a world where you dilute protein by adding extra calories in the form of other macronutrients, whether that be fat or carbohydrate, doesn't really matter, then the animal will overconsume total energy to attain its target intake of protein. It will care more about getting to that intake of protein than it will about over-consuming everything else. That's what we call protein leverage. And the protein leverage hypothesis is when that mechanism interacts in a food environment which is diluted in protein and drives excess energy intake, which then predisposes to an increased risk of obesity. And so the protein leverage hypothesis was that mechanism, protein leverage, is what has driven over the last 50 or 60 years the emerging global epidemic of obesity and associated comorbidities. So I think that sort of captures it. Dave, is there anything else that you wanted to add to that?
Just the important point that in terms of these nutrient-specific appetites, so this is one example where an evolutionary background can help you to identify and ask the right questions in biology. That is, as with a background in evolution, we know that animals need lots of nutrients to satisfy their various needs. And the simple question we ask is, well, how do they satisfy all of these needs? Just choosing foods won't do it because, as Steve said, foods are really complex mixtures. And very few animals feed on a narrow range. They have to feed on a wide range of foods for all sorts of reasons. So what they've evolved, we postulated that they would have specific mechanisms that enable them to link their bodily needs to whatever that nutrient is in foods in the environment and select accordingly when they need a particular nutrient or they've had enough of another nutrient. And that exactly is the role of these nutrient-specific appetites, is that the way that the body tells the animal's brain what it needs at a given time so it can direct its behavior, its foraging and feeding behavior appropriately.
The problem with trying to solve that challenge is that you can't, we find it hard to believe that you could evolve a system which has 100 different specific appetites for all the different micro and macronutrients that are required. So evolution's had to tackle that problem too and try and hone in on a relatively small number of nutrients that are collectively a signal for a balanced diet through the correlations that occur in natural foods between that smaller number of nutrients and everything else. So if you regulate your intake of protein, you end up getting a whole bunch of other micronutrients satisfied at the same time. And you can get by with 5 appetites rather than 50 appetites, but you can't get away with just one appetite, let's say for calories, because that won't do it. You won't balance your diet appropriately.
So I think it's kind of interesting. We have these 5 appetites, or most animals have 5 appetites, as I understand it, and in humans too. And it's protein, carbs, fat, sodium, and calcium. But is there any kind of regulation of calorie intake, or is that handled through the other appetites?
Well, calorie intake is achieved as a consequence, in a sense, of managing those other appetites. And we do have an energy balance regulatory physiology as well, of course. It's just that some of the other appetites can overwhelm that regulation. So the protein appetite will encourage you to consume more calories than you need, even though your caloric regulatory physiology may not be requiring them. You need to eat them to get sufficient limiting protein, and that protein appetite is the imperative that maintains you to continue to consume foods in that environment. So calories, yes, of course, energy is regulated. It's the fundamental component of the biology of all organisms. Those calories, however, come from fuels, and what the biochemistry of appetite does is use those fuels as the keys for regulating ultimately its intake of calories. And then, of course, cellular processes, mitochondrial process and others deal with the energy side of the equation.
Which, in a sense, just illustrates how different the protein leverage phenomenon is, that what it proposes, or we know in humans from a number of sources now, is that the reason that humans overeat fat and carbs and energy is not because we have a strong appetite for calories, but because we have a strong appetite for the third, principally non-caloric macronutrient, which is protein. It's an entirely different focus, and it's an important focus because it means we can then look we can direct our searches in the food environment for the causes, not at calories, but specifically at protein. And that's what we've been doing in a lot of our recent work, is trying to understand how it is that this protein appetite can or does drive excess energy intake in changed human environments.
So if I'm going to just try to clarify, so protein leverage is basically the idea that even though we have multiple appetites, when we are forced to eat an imbalanced diet for whatever reason, we're going to prioritize protein, and protein is going to control how much or how little we eat. So if we eat foods that are very high in protein, we're going to eat less overall. If we eat foods that are low in protein, we're going to eat more overall.
Yeah. One qualification there is it doesn't necessarily take us to be forced to eat low-protein foods. A better word is coaxed, because nobody forces us to eat what we eat in modern food environments, but we're certainly coaxed to choose some things over the other by marketing, by differences in palatability, by culture, all manner of things. So those are the things we've got to think about in trying to understand what's happening in our environment and its interaction with our whole biology.
So that's actually a really important nuance in our thinking. So the protein appetite and the non-protein calorie appetites, particularly fat and carbohydrate, in an appropriate food environment will work together. So when you need more protein, you'll select a higher protein food in your environment, and in that way you'll balance your intake, and vice versa when you are shorter in protein, in fats and carbohydrates. Whereas if you're confined to a diet and you've got no alternative, then these appetites come into conflict with one another. And that leaves you with a bit of a paradox. You might think in the modern food environment, we have endless choice to select appropriate foods when we need the nutrients that they're particularly rich in. And we're certainly not short of high protein foods either in the modern environment. But we don't. We act as if we're stuck on a protein dilute diet, which, if you look at the food supply and indeed any individual diet, we are in many cases on a protein dilute diet. And the reason we are is that we've been led astray by the food environment. So you're misdirected. Your appetites would work together and take you exactly to where you need to be. But in the modern food environment, we're just led off course towards lower protein, higher fat and carbohydrate. And there are many reasons for that, but it all comes back to the design of the food system, and particularly the design of the ultra-processed food environment.
This gets back to an important point that Steve raised earlier about there being natural correlations in foods. That one of the things that correlates in the wild, both for humans, in hunter-gatherer populations and all species of non-human primates that we've studied, is that the sources of carbohydrate come inextricably mixed with high fiber content, whether it's in fruit or whether it's in the form of leaves or anything else. It's very difficult and unusual to find sources of carbohydrate that are free from fiber. I mean, honey is one of those, but believe me, it's very difficult to get in the wild, difficult to find and difficult to harvest. So it's an unusual thing. In the modern food environment, carbohydrates have been dissociated from fiber through industrial processing of foods. And that's a problem. Low protein combined with high carbohydrate without fiber. Very different to our evolved nutritional ecology.
That's another thing I really kind of want to touch on, the fiber thing. But I mean, so throughout our history, we've always been able to balance our intakes of protein and carbs. I mean, obesity is a modern phenomenon, and yet like you say, I mean, if we go into a supermarket, there's nothing preventing us from going to the meat aisle and buying meat. I mean, why are our appetites not just directing us in the modern food environment to make these correct decisions? I mean, if we're eating a protein dilute diet, why don't we just feel this insatiable need for meat that causes us to go and buy the right things in the shop?
Well, a perfect example is what we call protein decoys. So one of the really abundant foods in the modern environment, you walk into a supermarket, the savory snack foods, and they're foods that have been designed to taste like protein, but to be nothing more than fat and carbohydrates. And they're quite literally decoys that have been designed to tap into the physiology of our protein appetite system, which is that when your protein levels go down, you have release of particularly hormones like FGF21 from the liver, acts in the brain, and it increases the salience of umami and savory flavors. So they become suddenly very attractive and things that you crave. And if the nearest thing is a packet of potato chips, barbecue flavored, then those cues, those sensory cues, are exactly those cues that our sensory systems have evolved to associate with high protein foods. And you'll eat that, your protein appetite is unsatiated, and you've taken on a load of excess calories that you didn't need. So that's what we mean by being misdirected. There's a siren call coming from the food environment that takes you away from that. In the same way that meat is what? Game meat, natural game meat is probably 2 or 5% fat. Modern farmed meat, even lean meat, is what is it, Dave? It's 20% fat or something of that order. So it's diluted. Protein is diluted even in modern meat. So we're in an environment where our protein is diluted in the overall food supply, and these siren foods, these protein decoys, for example, are specifically designed to tap into that protein appetite regulatory biology.
There's that, and the other factors. A lot of the foods that are very heavily marketed are low protein foods. So you've got advertising, you've got marketing working against your choices. The other thing is that protein is a more expensive macronutrient than either fat or carbohydrate. So economic considerations would cause people to reach for the fattier cut of meat rather than the leaner cut of meat, for example. And the other is that new correlations are created, the correlations we've spoken about in heavily industrially processed foods. For example, the mixtures of fat and carbohydrate and protein in many processed foods are what are known as hyperpalatable. They're unusually palatable. They're mixtures, they're combinations that aren't found in any form in natural human foraging environments. And they're designed to do that. Palatability is part of the strategy of sales for processed foods. So all of these factors, this is why I use the word coaxed rather than forced, because we're not forced to eat it, but we're coaxed to eat it. Our nutrient selection mechanisms are diverted through processes, like Steve said, decoys and other processes.
One of the really, I think, striking examples that shows that our physiology our regulatory biology is kind of working, and it is being misled by not as much as it should be, is if you look at the food supply and the relative abundance of fats and carbohydrates, particularly highly processed ones, relative to the actual dilution in our diet of protein over the last, say, 50 years. There's been a decline, if you take the data out of, for example, the US, in only about 1 or maybe a touch over 1% of protein in the energy supply. And that's of itself testament to how good we are at regulating. We've been faced with this extraordinary diversity of foods. You walk into a supermarket now and there's now 30,000 different types of thing, all of which are essentially low, well, not all of which, but many of which are low in protein. And our regulatory biology has stopped us from completely diluting protein. We've only diluted it by about 1% in the food supply over those years. But that's sufficient through protein leverage to drive a 10 or 15% increase in calories. And that comes down to simple Euclidean geometry. It comes back to nutritional geometry. Our habitual protein percent of total energy intake is only in the human diet between 10 and 30%, typically about 15%. And only a small dilution of that can leverage a huge intake in total calories. So that's the problem. Our biology is working. It's just that we're being coaxed in our modern environment away from hitting exactly the target. We're being pushed a little bit away towards a protein dilute diet. And because of protein leveraging up total calorie intake, that's what's causing us terrible problems.
And we've also shown in experiments, in highly controlled, randomized controlled experiments, that humans in a situation where they're not exposed to the marketing and to the financial pressures and to the hyperpalatability, they select a diet of 15% protein, energy from protein, which aligns remarkably well with what we see at a population level and also a global level. There's a very strong signal of that 15% being an important number for human nutritional biology.
Bearing in mind that it changes across the life course as well, and that's another really interesting dimension. So the optimal percent protein in the diet changes from when you're an infant, breastfeeding infant, all the way through to your decrepitude in your very old years. Your nutrient needs change. They change with your lifestyle. They change with your genetic background. They change with your disease status and many other things. So it's a moving target. It's a target that changes over time.
Okay, so you mentioned that it's quite a small reduction in protein intake can really be enough to drive a lot of weight gain. So it's kind of enough that you go from 15% protein down to 12%, and that's enough over a few decades to massively increase the proportion of people who are obese. Thinking then logically it should be possible to cure obesity just by doing the opposite, just by massively increasing protein intake. So should everyone who is obese start following a carnivore diet, or?
Well, just as a small dilution of protein can drive a large increase in total energy intake, so can a relatively small increase in percent protein easily achieved by dropping fat and or carb intake. That can lead to a pretty substantial energy deficit as well. So protein leverage isn't quite as strong in both directions. You can overeat protein. Your body will allow you to do that with greater ease than allowing you to undereat it, because clearly the costs of undereating protein are substantial. You pay the price in all manner of ways to do with growth and development and reproduction and maintenance of tissues. But you don't need to go to 40% protein to get the benefits of an increase in protein. You need to simply chase your target. But you're right. As a therapeutic intervention, increasing the percent of protein in the diet is a very simple way to reduce calorie intake and hence to promote and maintain weight loss. And there are many trials that indicate that that's the case.
So if you wanted to help someone lose weight, would you prioritize maximizing fiber intake, or would you prioritize increasing protein intake, or is both best?
Both, yeah. And you would increase the proportion of protein by removing the simply digested fat and carbohydrates. Very easy. It's easier to do that than to try and eat more protein. In fact, that's the whole point. The system doesn't like you eating more protein. And if you listen to that protein appetite and you ensure that you've got plenty of fiber such that your calorie intake is commensurately lower, then you can get the best of both worlds. If you then go back onto a lower protein diet because it's the healthy thing to do when you're in midlife and you're not diabetic and suffering from overweight or obesity, then make sure that that lower protein is accompanied by lots of fiber in plant, and it has to be almost inevitably a plant-based diet to allow you to do that, because our principal sources of fiber are actually found in plants, structurally found in plants.
So I wanted to end with talking a bit about the obesity epidemic, and you point in the book at ultra-processed foods as the primary cause of the epidemic. Why is it that? What is it about them? And since, like we were talking about, there's nothing inherently that says that processed foods need to be unhealthy, that means they're intentionally being designed in a way that's making them unhealthy. And why is that? Why are they being designed in this way?
They're not being designed specifically to be unhealthy. Of course they're not. They're being designed to be competitive in the marketplace. And that comes with a number of things. The first is we've already said low protein. Protein is expensive relative to fat and carbohydrate. A mixture of protein to fat and carbohydrate, that's an unnaturally palatable mixture. That in itself makes them attractive. Low fiber. It concentrates that mixture, so it's more readily exposed to palatability system. Heavy marketing, because they're more profitable to produce than selling whole food. So all of these factors work together to ensure that we choose to eat those foods to which our regulatory systems, our appetite systems are not adapted to regulate the amount that we eat. That is why I think that ultra-processed foods in abundance in a food system, as they have become in the past 40 or 50 years, are a real risk. And we're seeing the consequences of that now.
And just building on what David said and taking us back a little bit to the changing protein target idea, it puzzled us for a little while if suddenly the world had been flooded in the 1950s, 60s, 70s with these hyper-palatable foods, which we found irresistible and we bought and we ate more of, and made us fat. Why did we continue to get fat? Because you would presume that if you overconsume calories, you would put on weight, but you would need those extra calories because you were bigger as a result. And you would predict that the obesity epidemic should have plateaued, but it didn't. It continued to accelerate. So something was driving it. And what we realized fairly early on, and it's been demonstrated time and again now, is that as you become insulin resistant, as you start becoming metabolically sick, and that happens as an accompaniment to overweight and obesity, your protein target goes up. And it goes up for various reasons. Insulin normally inhibits proteolysis in lean tissue, bone and muscle. So you don't normally burn your own lean tissue unless you need to. And your liver doesn't normally subject protein and amino acids to gluconeogenesis to produce glucose, unless you're starving either. But both of those systems start to become disinhibited as a result of insulin resistance. So your protein target goes up. You're chasing an ever-increasing protein target, and that is amplifying the protein leverage problem. And even in recent studies, in mice, but they're really, I think it's a powerful illustration, you can shift the protein target across generations according to the diet you feed the mother during pregnancy. So we fed high protein or low protein diets to dams, to female mice who were pregnant, and found that their offspring had a higher protein target if their mother had been fed a high protein diet. And that put them at greater risk of obesity on a low protein diet. So you're born with a protein target set too high. And we think that also explains some of the association between formula-fed infants and their higher risk as children and adolescents, particularly formula that has a higher than breast milk level of protein. So there's a whole series of really interesting pieces of our biology here that are starting to become uncovered as a result of looking at nutrition through this different lens.
That formula example, that infant formula example, really nicely illustrates the problems and dangers of thinking about human nutrition in terms of single nutrients, because the background to that, of course, is we all know that protein is important for growth. So the rationale was, if protein is important for growth, we're looking at an important growth phase of the life cycle, let's increase the protein level. But without understanding the nuances of ratios of protein to other macronutrients and also the evolutionary context, because if you look at primates as a group, they have low protein in the milk and they grow slowly. And this is almost certainly a deliberate evolutionary strategy to enable them to develop the slow growth period, provides a long learning period to enable them to develop the skills they need to live in complex social systems. So an evolutionary perspective and a multiple nutrient perspective would have avoided that in the way that we're now able to explain using nutritional geometry and nutritional ecology.
I wanted to end with a final question about the obesity epidemic. Do you think it's realistically possible to turn around, and what do you think in that case needs to happen for that to become a reality?
I think it is possible to turn around, and what gives me confidence is there are precedents. Cigarette smoking is an example where when I grew up, if you asked me that question about cigarette smoking, I almost certainly would have said no. Probably not possible to turn around, but it worked. How does it work? It works if you take a complex systems approach to the problem. Bad diets and obesity aren't just due to the food industry. They're not just due to poor consumer choices, and they're not just to poor government regulation. They're due to the meeting point of all three of those things. The way that we'll turn it around, in the same way as we turned around the epidemic of cigarette smoking and associated cancers, is to find a way, a forum in which those three groups can come together and reach a consensus as to how we can all find a way forward where we benefit and society benefits as a whole. And I believe those solutions are out there. There's nothing intrinsic about unhealthy foods that makes them more profitable to industry than healthy foods. The issue is their composition and the extent to which they are overeaten and distort diets. But people have to eat. In their place, they will be buying other foods. A policy would benefit because there's nothing more satisfying to a government than a healthy population, a productive population, and of course consumers would benefit. We just need to find the way of getting those groups together and charting a way forward.
And we can take heart in the fact that our biology still works. there has been the view that our biology is broken and our appetites no longer work. They do if you put them in an appropriate food environment. So there's the good message. It's putting our biology, which has evolved and works exquisitely in the appropriate environment, back into that appropriate environment.
And that's a really important message, because it contrasts with what I was speaking about. I'm speaking about societal solutions. What Steve's referring to here, I'm speaking about changing our food system and our food environment as a society. What Steve's referring to is changing our personal food environments, exposing our natural evolved biology to food environments in which they evolved to operate. All animals do that. They operate really efficiently within the appropriate environment. And all that takes is ensuring that when your appetites are urging you to eat, they're exposed to foods that they can cope with. In other words, not heavily processed ones, but whole foods, or a good combination of it.
Thank you so much, David and Stephen, for coming on and talking to me today. I really enjoyed our conversation, and I really enjoyed your book, Eat Like the Animals. I hope the people listening will also be curious about buying and reading it. Thank you so much.
It's a pleasure, Sebastian.
Thanks, Sebastian. I've really enjoyed that conversation.
Guess what? What you just listened to was not the full interview. In order to get access to the full-length, uncut version of the interview, you'll need to sign up as a patron, which you can do at patreon.com/Sebastian Rushworth. Patrons get access to a private podcast feed with full-length versions of all the interviews I do. They also get access to my private forum and all the interesting conversations happening there. And they gain the ability to send me private direct messages. I always respond to messages from my patrons. So please support my work by becoming a patron and signing up at patreon.com/Sebastian Rushworth.